Welcome. We are now going to do the 8 question practice problems for monohybrid crosses, and like always you want to read the directions first before you start doing your problems. So it looks like here for my directions it says symbols, parents, and a Punnett square for the offspring. So let's see what my trait is that I'm looking at, and then we'll do our symbols. So a cross between a homozygous dominant red plant and, there's my cross, a homozygous recessive white plant. So it looks like we have the color of the plant. So I've got red and I've got white. And it says here that red is dominant, white is recessive. So we're going to, it doesn't tell me the letter, but let's go ahead and use an R. So capital R for dominant, lowercase r for white. Cross a homozygous dominant, so that will mean 2 capital R's, and homozygous recessive, 2 lowercase r's, and then my Punnett square. We don't need that. And then you fill in one parent on top, one parent on the side, and then match with dominant letter first. So that should be review from our last worksheet. Question number 2, cross a heterozygous flower which is red in color and a homozygous recessive, that should be recessive white flower. So in this case red is dominant, so I've got red and I've got white, and we'll use R's again. Heterozygous, one of each letter. Homozygous recessive white, can only be that way. Make a Punnett square. Dominant letter first, and then always go back and double check my parents. So there's heterozygous, here's homozygous recessive, and then just double check that I put all the correct parents, and because sometimes you get going pretty fast and then you just skip something. Number 3, cross 2 heterozygous peas. Round is dominant over wrinkled, so I've got round, wrinkled. We'll use R's again. So round is dominant over wrinkled. 2 heterozygous plants, so that means that both parents have one uppercase and lowercase r. My Punnett square. That's homozygous dominant, heterozygous, heterozygous, homozygous recessive. Number 4, cross 2 homozygous plants. One is dominant and the other is recessive. Just a different way to word it. Means the same thing. It tells me broadleaves is dominant over narrow. So I've got the shape of the leaves is my trait, my monohybrid trait. So I've got broad and I've got narrow. So let's go ahead and use the letter B. So broad is dominant. Narrow is recessive, so lowercase. 2 homozygous plants. So one is dominant, so that's going to be 2 capital B's, and the other one is recessive, 2 lowercase b's. Punnett square. And this one's going to be heterozygous, 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 heterozygous. And remember, we can also use the term hybrid on that. Okay, now number 5, now we're going to add another layer to these problems besides symbols, parents, and a Punnett square. Now we're going to be looking at geno and phenotypic ratios, and what are the offsprings going to tell us. So let's set everything up just like we've been doing. So in foxes we have silver coat is governed by the recessive allele, so this time I just flipped around because usually I give dominant first, but so I've got silver is recessive, it even gives me the lowercase b, and red is going to be dominant. So I've got the color of the coat, so red and then silver. Determine the genome phenotypic ratios from the crossing. There's my cross. Heterozygous red, so that's going to be big B, little b. And silver, the only way it can be silver is homozygous recessive. Covered that several times. And let's make our square, because we need to answer a couple of questions. We need to know geno and phenotype, so we have to do this first. So there's heterozygous, homozygous recessive, heterozygous, and then homozygous recessive. So let's talk about geno and phenotype. So geno, let me just write that out for you. So geno are your genes, and you're going to look at both letters. And the letters I'm talking about is the offspring. So we got 4 different offspring. We're going to look at both letters in each box. Pheno is the physical. What does it look like when I look at it? In this case, we're going to look at the first letter, because remember, dominant is going to mask any recessive trait. So that's why we look at the first letter. And that's why we also want to try, when we're matching these back up, that we put the capital letter first, if there is one, not lowercase b, capital letter. Okay, so let's do geno first. So let's do genotype. It asks for the ratio, but I'm going to go ahead and write it out. So genotype is both letters. So my first possible combination is big B, little b. I will have 2 that will have that combination. My next possibility is big B, little b. I will also have 2. So the genotypic ratio, notice the wording's a little bit different. So we got genotype is this, and the genotypic ratio, I take these numbers and put it in a ratio format. Now I can reduce this, and I'm asking you for this particular class, we are not going to reduce it because we're just learning this. But when you get into an upper level class, you could reduce that 1 to 1. But for right now, we're just going to keep that 2 to 2, knowing that if we add that together, we will come up with 4 offspring. Okay. Let's go ahead and do pheno now. So phenotype. Phenotype, what does it look like? So I look at the first letter of each. So my first letter, I don't use the letter B, that's a symbol. Now I'm going to do red. If I actually looked at a fox, the phenotype, it would be red. And my other trait is silver. So don't use symbols in this case. So red, I've got 2 offspring that will be exhibiting the red color, and then I will have 2, looking at the first letter, that would be silver. So then my phenotypic ratio, in this case, just happens to be 2 to 2. Sometimes it's the same and sometimes it's not. Okay, so let's go ahead and do number 6. Now in domestic poultry, you have chickens with a rose comb and a single comb. Those are the little things on top of their head. We want to cross a homozygous rose comb rooster, the male, with a single comb hen, the female. From the parental cross, give the phenotypic ratio. Also cross any 2 offspring. From the F1 cross, give the phenotypic ratio. Okay, I've got 2 different problems going on here. So I'm going to make a line here. So I'm going to look at the parents. I'm going to do the parental cross just like I've done before. And then it asks me to cross any 2 of those offspring and give me those results. So basically we're looking at grandparents, parents, and grandkids. We want to look at it that way. Let's start with my symbols. So I've got rose is a capital R. I've got single is a lowercase r. And then my first cross. Now this is my parental cross. Remember how we use the symbols P1, F1, F2? This is where this is going to come into play. So this is my P1, my parental, right here. Okay? So my P1 cross is a homozygous rose. So 2 capital R's, that's the rooster. Homozygous single comb, the only way it can be single would be homozygous recessive. Now since I'm going to have 2 Punnett squares, I'm also going to go ahead in this one box that I usually kind of mark out, I'm going to put P1 because I've got 2 different problems here. And let me go ahead, I've done the Punnett square before, making sure I pay attention to what I'm filling in. Now it wants me to know the phenotypic ratio. So my phenotype would be 4 rose comb, but it wants the ratio. So in this case, it's going to be 4 to 0. Okay? 4 rows, no single comb. Yes, you do need to put a 0 afterwards to show that it is in ratio format. Now, for the second half of the problem, it tells me to cross any 2 offspring. All 4 offspring are the same. So this is my F1, so I can choose any two. So heterozygous for both. Now I make my Punnett square, and again I'm going to go ahead and label this F1, because if I want to make another cross, it would be my F2 cross. So that's why I'm labeling my Punnett squares and my parents as I go along. Okay, then it wants phenotypic ratio. So my phenotype, what it looks like, so rows, I would have 1, 2, 3, and then single, I would have 1. So my ratio, my phenotypic ratio, is 3 to 1. Now they're different. Most cases before we've been having the same pheno-geno, all the ratios have been the same, okay, but this case it's not. If I went back to my original problem and I asked for the genotypic ratio would also be 4 to 0. However, on this one, for my F1 cross, my geno would actually now be 1 to 1. So I have 1 that's homozygous dominant. I will have 2 that's heterozygous. And then I will have 1 that's homozygous recessive. And that's why it's written 1 to 1. So it's always homozygous dominant if it's available, and then it'll go down to heterozygous, and then lastly would be homozygous recessive. Now, number 7. We've got black fur is dominant to white fur. Pure black is crossed with white, and then it wants to know the fraction of offspring that's heterozygous. So fur color is my trait. I've got black. Let's just use bees again. And I've got white. Pure black is 2 capital B's. White, 2 lowercase b's. So 1 parent on the top, 1 on the side. And my question, the fraction of offspring that's going to be heterozygous. Heterozygous means 1 of each of the allele, 1 of each letter. So in this case, 4 out of 4 are heterozygous. So all of them will be heterozygous. I want to leave it in fraction because that's what the question asks. If it wanted percent, I would do a 100%. Okay, and again, don't reduce for this purposes. And finally, number 8, purple is dominant to white. Homozygous violet, don't be thrown, I just changed the wording. Violet and purple are the same. Cross with the heterozygous violet, and in this case it wants the geno and phenotypic ratios. So purple, same as violet, and white. I wouldn't use P because that's kind of hard to tell. Some letters I would stay away from would be O, P, C. There are some problems that have C, but those are more subscript, superscript type problems. S's, that's a bad letter to use. So let's just go ahead and we can use an R, would be fine. So R's. And then a dominant, or excuse me, a homozygous violet, so 2 capital R's. Heterozygous violet, so big R, little r. And let's go ahead and do our cross. Okay, so we want genotypic ratios. So I'm going to do genotype. And so the genotype, and if you need to write them out, go right ahead. So I'm going to have 2 that are homozygous dominant, and then 2 that are heterozygous. Okay? And then my ratio, because that's what it asked for originally, is 2 to 2. And then my phenotype, what does it look like? So I've got purple, don't use symbols in this case. White, purple, the first letter of each, so they're all going to be purple. There are no white, so my ratio is 4 to 0. So when you're looking at ratios for the monohybrid crosses, you could have, and we've seen some of these already, we've seen 2 to 2, we can see 1 to 1, 4-0, and 3 to 1. So those are your possibilities, and that's how they're written. So, like always, if you have any questions, make sure you contact me, and if not, just have a great day. Thank you.